Hey guys, good morning. This morning in Math 8, we're going to do Chapter 3, Section 5, and let's get started. So, the last section we looked at, we are still solving equations, right? And we're solving equations that have a variable on both sides. So we learned how to do that last time. It was quite easy, I think. Maybe you have 2x plus 3, and maybe you have 5x minus 12. And what you need to do when there is a variable term on both sides is you need to take one of those variable terms, the 2x or the 5x, and eliminate it by adding or subtracting, right? So in this case, I might subtract 2x from both sides. And I would be left with 3 equals 3x minus 12. And then I could start getting the variable by itself. So we are still going to be looking at equations that have a variable on both sides, like this. But we're going to look at a unique situation today, and that's it. When you solve an equation that has a variable on both sides, it is possible that a unique situation happens. And that is when you go to eliminate the variable from one side of the problem, the variable term gets eliminated from both sides of the problem. Uh-oh, no more variable in the problem. What now? And I have a couple examples of that happening here. So on the left, I have a variable term on both sides, right? And it's the same variable term on both sides. So when I go to eliminate one of them, as you can see, both of them end up eliminated, and I have 7 equals 9. And there's no more variable left in the problem. What do you do then? I'll get to that. I have this other problem over here that needs simplified first. So here I would distribute the 3, right? And get 12x plus 6 minus x. And I would combine my like terms and get 11x plus 6. And on the other side of the problem, all I have to do is combine my like terms, and I also have 11x plus 6. So again, I have a variable term on both sides, and it's the same variable term on both sides. So when I go to eliminate the variable on one side, the variable gets eliminated on both sides, and I'm left with 6 equals 6. Let's look and see what this means when this happens. So what happens if the variable cancels out of the problem? Well, the good news is you can immediately stop trying to solve the problem. And one of two things happens. Either you are left with, you will be left with a statement. That is what I call this. 7 equals 9. That is a statement. Or 6 equals 6. That is a statement. If the statement is false, then the original equation is always, or you know what? I like the word better in there, never, is never true. And we say that the solution is no solution. So I have an example up here of that on the left. Right here, I got a statement that was false. And because that statement is false, that tells me that the original problem, this problem, will never be true. No matter what number you replace the x with, there is no x value that will make that equation true. And because there's no x value, I mean, think about it, can 3 times x plus 7 ever equal 3 times x plus 9? It can't happen. And so we say that this problem has no solution. On the other hand, if the statement that you are left with is true, then the original equation is always, a little trouble spelling always there, is always true. And we say, when that happens, that the solution is all real numbers. Basically, any number will work for the variable. And I have an example of that back here, right? So in this problem, the one on the right, I got 6 equals 6. Well, 6 equals 6 is true. Oops. And because it's true, that tells me that the original problem will always be true. No matter what number I stick in for the variable, any number will work. And so the solution is all real numbers, which basically means every number is a solution, right? All right, so these are the two things that can happen if the variable cancels out of the problem. It's always one of these two answers if the variable cancels out of the problem. What if the variable does not cancel out of the problem? Well, then you get an answer, right? All right, so let's look at a couple examples here quickly. This one on the left, before I can solve this, I need to simplify it, right? I would distribute the 5, giving me 10 minus 5x plus 7x. And I would combine my like terms here and get 10, and a negative 5x and a positive 7x gives me a positive 2x. The other side does not need simplified. It will just stay 2x plus 7, right? So now I have a problem that's got a variable on both sides. When I have a variable on both sides, I eliminate one of them. I'm going to eliminate this 2x by subtracting 2x from both sides. And of course, you can see what happens. The variable got eliminated on both sides. And I am left with 7 equals 10. What does that mean? It means this problem has no solution. And I write no solution as the answer. All right. Obviously, you guys, what I'd like you to notice is, when does the variable cancel out on both sides? When does it cancel out on both sides? Well, it cancels out on both sides when it's the same variable on both sides, right? If you have a 2x on both sides, of course it's going to cancel out. If you had a, if you had a 3x on both sides, of course it's going to cancel out. Okay, when the variable term is the same on both sides, it's going to cancel out. Do you want to be a little bit careful? Look at this next example. Is the variable term the same on both sides? It's not, is it? When you go to cancel out the negative 2x here, you would cancel that out by adding 2x to both sides. So negative 2x and positive 2x cancels out. But if you add 2x to this side, it does not cancel out. It equals 4x. Those two had different signs on them. One was negative, one was positive. So it's not the same on both sides. And if it's not the same on both sides, you're going to get one answer. And here my answer would be subtract 11 from both sides, get negative 8 equals 4x, and finally divide by 4, and I get x equals negative 2. So I got an answer, right? I got one answer. All right, so here's where we stand. If the variable cancels out on both sides, you're going to get either no solution or all real numbers. But if the variable does not cancel out on both sides, of course you get an answer. Let me show you one more thing and we're done. So you now know that when you're solving an equation, you might get one solution, like you've gotten in every problem up until today. Or now, you also might get no solution. That would be if the variable cancels out of the problem and you're left with something that is not true. Or you might get all real numbers as your solution. That happens when the variable cancels out of the problem and you're left with a true statement. Now, what I'd like you to be able to do is immediately look at the problem and tell. Is the answer going to be one solution? Is there going to be a solution? Or is the answer going to be no solution? Or is the answer going to be all real numbers? Can you look at the problem and just tell that? Let's start with A. You think about it quickly. What do you think? One solution, no solution, or all real numbers? Well, of course, the variable is the same on both sides, right? So when I go to eliminate the 3x on one side, it's going to get eliminated on both sides. Am I left with something that's true or false? Well, false, right? We all know that 7 does not equal 5. So because that's false, this one is no solution. Can you do them all that quickly? How about the next one? Is the variable going to cancel out on both sides? Of course it is. It's the same variable term on both sides. So when you go to eliminate one of them by adding 2x, both of them get eliminated. But this time you're left with something that's true. What does that mean? Well, that means the answer is all real numbers. How about letter C? What do you think? One, none, or all? I think you got it, right? This time the variable is not the same. So it's not going to cancel out of the problem if it's not the same. And therefore, you're going to get an answer, right? How about letter D? It's one of the trickiest kind for a lot of people. Is there the variable term the same on both sides? Nope. Over here you have a 4x, and over here you don't even have a variable. So you're going to get an answer. And let me show you real quick, because this confuses a lot of people. When I go to get the variable by itself, by adding 11 to both sides, I am left with 4x equals 0. A lot of people don't like the 0. Don't be one of those people. 0's a number just like all the other numbers. He's okay. I would finish this off by dividing by 4, and I would end up with x equals whatever 0 divided by 4 is. It's 0. X equals 0 is the answer. Just like if it was x equals 7. 0's a number too. All right, last up. Ooh, this one needs simplified. If I simplify it, I would get 2x plus 12. Okay, is this going to be one, none, or all? Let's see. The variable is the same on both sides, so it's going to cancel out on both sides. This one is none, right? Because 12 is not equal to 15. And finally, let's see. The variable term is the same on both sides, so it's going to cancel out. When I cancel it out on one side, it's going to cancel out on both sides. And that leaves me with -9 equals -9, which is true. So this one would be all real numbers, right? You got this. Good luck on the homework.